National Electrical Code Section 230.24 addresses minimum clearances for service drop conductors. This section is crucial for ensuring safety and compliance when installing or modifying electrical services. The specific part of the code we're discussing states that where outside conductors are attached to a building or other structure, the conductors must be guarded where necessary. Additionally, clearance must be provided so that no portion of the conductors will be less than 3 meters, which is approximately 10 feet, from windows that are designed to be opened. The code also states that the clearance must be less than 3.7 meters, which is approximately 12 feet, from ground or from any platform or projection from which they might be reached. Understanding the nuanced application of the 10-foot and 12-foot clearance rules is essential. The 10-foot vertical clearance rule in Section 230.24 specifically applies in 2 scenarios. Firstly, it applies to conductors that are attached to a building or other structure. Secondly, it applies to conductors that are within 3 meters or 10 feet of windows that are designed to be opened. These conditions highlight that the 10-foot clearance is relevant when the conductors are in close proximity to buildings or operable windows where accidental contact is a potential concern. In contrast, the 12-foot rule has a broader application. It applies to any portion of conductors that are over residential property. This means that if the service drop conductors run above any part of a residential property, the minimum vertical clearance must be 12 feet. This requirement aims to ensure the safety of residents and prevent accidental contact with the electrical service. Let's consider a practical example to illustrate these rules. Imagine a situation where the power company service drop conductors run along the property line of a residential property. As the conductors approach the house, they descend to a height of 11 feet at the corner of the building. If the maximum point of attachment, the power, can only be 10 feet 8 inches without installing a mast, there will be a violation of the code. If the inspector rejects the installation due to a perceived violation of the 12-foot clearance rule to the drip loop, you must assess the situation according to the NEC. In this case, because the conductors are positioned over residential property, the 12-foot clearance rule takes precedence. The fact that the conductors are 11 feet above the ground at the corner of the house does not meet the minimum clearance requirement. Therefore, a mast installation is necessary to raise the point of attachment and ensure that the conductors achieve the required 12-foot clearance. It is important to remember that the 12-foot clearance rule applies to any portion of the conductors that are over residential property. This means that the entire span of the service drop conductors above the property must maintain a minimum vertical clearance of 12 feet. In situations where the existing service drop conductors do not meet this requirement, a mast must be installed to raise the point of attachment and provide the necessary clearance. When working with electrical service installations, it is crucial to consult the most recent edition of the National Electrical Code, as well as any local amendments or interpretations. The NEC provides detailed guidelines for safe and compliant electrical installations, and it is essential to follow these guidelines to protect both people and property. In summary, the 10-foot vertical clearance rule in Section 230.24 applies only to conductors that are attached to a building or other structure, as well as conductors that are within 10 feet of windows designed to be opened. The 12-foot rule applies to any portion of conductors that are over residential property. In the specific example discussed, the conductors are over residential property, so the 12-foot clearance rule applies. Therefore, a mast must be installed to meet the minimum clearance requirement. Understanding these rules and their applications is critical for ensuring safe and compliant electrical service installations. Remember to always consult the latest edition of the NEC and any local amendments or interpretations for the most up-to-date information and guidance. Additionally, it's always best to consult with a qualified electrician for any electrical work, especially when dealing with service entrances. They are trained and experienced in interpreting and applying the electrical code and can ensure that the installation is done safely and correctly. Neglecting these clearances can lead to dangerous situations. Low-hanging wires can pose a shock hazard to people and equipment. It can also increase the risk of damage to the service conductors. Furthermore, not adhering to code requirements can result in failed inspections, fines, and potential liability. Therefore, it is crucial to prioritize safety and compliance when working with electrical services. The National Electrical Code also addresses clearances from other structures such as signs, chimneys, and communication lines. These clearances are important to prevent contact between electrical conductors and other objects. They also ensure safe access for maintenance and repairs. For example, conductors must maintain a certain distance from signs to prevent accidental contact by workers installing or maintaining the sign. Similarly, conductors must be kept away from chimneys to avoid damage from heat and smoke. Clearances from communication lines are also crucial to prevent interference and ensure the proper functioning of communication systems. Another important consideration when installing service drop conductors is the type of insulation used. The insulation must be suitable for outdoor use and capable of withstanding the elements. It should also be resistant to abrasion and mechanical damage. In areas with harsh weather conditions, such as extreme temperatures, high winds, or heavy snow, it may be necessary to use specialized insulation that is designed to withstand these conditions. The size of the service drop conductors is also a critical factor. The conductors must be large enough to carry the expected load without overheating. The size of the conductors is determined by the ampacity, which is the maximum current that the conductors can safely carry. The ampacity is based on the conductor material, insulation type, and ambient temperature. It is essential to select the appropriate conductor size to ensure that the electrical system can operate safely and efficiently. In addition to the service drop conductors, the service entrance conductors must also meet certain requirements. The service entrance conductors are the conductors that run from the service drop to the service equipment, such as the main breaker panel. The service entrance conductors must be protected from physical damage and must be installed in a raceway, such as conduit. The raceway provides mechanical protection for the conductors and also helps to prevent the spread of fire. The service equipment must also be properly grounded. Grounding is the process of connecting the electrical system to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding system must be installed in accordance with the National Electrical Code. It is important to note that the National Electrical Code is a complex and ever-evolving document. It is updated every 3 years to reflect changes in technology and safety practices. It is essential to stay up to date with the latest edition of the NEC and any local amendments or interpretations. The NEC is not a substitute for proper training and experience. Electrical work should only be performed by qualified electricians who have the knowledge and skills necessary to do the job safely and correctly. If you are not a qualified electrician, you should always hire a professional to perform any electrical work. Attempting to perform electrical work without proper training can be dangerous and can result in serious injury or death. In addition to the National Electrical Code, there may be other local codes and regulations that apply to electrical installations. It is important to check with your local building department to determine the applicable codes and regulations. The building department can also provide guidance on permitting and inspection requirements. Obtaining the necessary permits and inspections is essential to ensure that the electrical installation is safe and compliant. Failing to obtain permits and inspections can result in fines and penalties. It can also create a liability risk in the event of an accident. The National Electrical Code provides detailed requirements for the installation of various types of electrical equipment. This equipment includes, but is not limited to, lighting fixtures, receptacles, switches, appliances, and motors. Each type of equipment has specific installation requirements that must be followed to ensure safety and proper operation. For example, lighting fixtures must be properly supported and must be installed in accordance with the manufacturer's instructions. Receptacles must be grounded and must be protected by ground fault circuit interrupters (GFCIs) in certain locations. Appliances must be properly connected and must be protected by overcurrent devices, such as circuit breakers or fuses. Motors must be properly sized and must be protected by motor overload protection devices. The NEC also addresses the installation of renewable energy systems, such as solar photovoltaic (PV) systems and wind turbine systems. These systems have unique installation requirements that must be followed to ensure safety and proper operation. For example, solar PV systems must be properly grounded and must be protected by overcurrent devices. Wind turbine systems must be properly located and must be designed to withstand high winds. The National Electrical Code is a comprehensive guide to safe electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential to have a thorough understanding of the NEC to ensure that electrical installations are safe and compliant. Remember, always consult the latest edition of the NEC and any local amendments or interpretations for the most up-to-date information and guidance. And always hire a qualified electrician for any electrical work. Understanding the clearance requirements for electrical service conductors is crucial for ensuring safety and compliance. Always refer to the National Electrical Code and local regulations for specific requirements and consult with a qualified electrician for any electrical work. By adhering to these guidelines, you can help prevent accidents and ensure that electrical systems operate safely and reliably.